just as we entered the region of Jupiter's magnetic field.
We learned more about two of our planetary neighbors this year, Jupiter and Saturn. Scientists launched rockets to improve methods of studying ozone in the Earth's upper atmosphere. Parts of the new space transportation system were assembled and rolled out to the launch pad in a major test. And the tilt-rotor research aircraft began making transition flights, one of a number of aeronautics programs underway. Jupiter, largest of the Sun's 9 planets, was photographed close up by the Voyagers 1 and 2 spacecraft. What their camera eyes recorded as they passed by the giant planet's churning clouds were ribbon-like streaks of red and brown and yellow. The wealth of data and photographs left behind by the Voyagers are providing scientists a valuable source of raw material to be studied. From Jupiter's newly discovered ring to the active volcanoes of Io, one of its 14 surrounding moons, the Voyager discoveries have surprised and delighted NASA scientists. Information that may one day help us better understand our own Earth. And the Voyager's mission did not end at Jupiter. The two spacecraft are now speeding toward a rendezvous with Saturn in 1980 and 1981. Acting as pathfinder for the Voyagers, Pioneer 11. The 570-pound spacecraft climaxed 6.5 years and a 2 billion-mile voyage in deep space as it swept by Saturn at 71,200 miles per hour. Scientists watched anxiously as Pioneer made its 2-hour passage of Saturn's rings. 4 times the spacecraft was hit by small pieces of debris, but emerged safely despite the collisions. Pioneer had a closer look at Saturn than all the observations that have been made in the last 400 years. Photographs show what appear to be jet streams swirling around Saturn at 300 miles an hour, a new ring circling the planet's equator, and radiation belts that are more like Earth's in their intensity and energy levels. The Pioneer 11 spacecraft, dwarfed by the objects it was sent to observe, is speeding out of the solar system in an endless journey. This is HEO-3, High Energy Astronomy Observatory, the last of a series of spacecraft designed to study deep regions of the universe where enormous amounts of energy are generated. Launched from Cape Canaveral, HEO-3 is now scanning the galaxies for gamma and cosmic rays in an effort to find clues about radiation from exploding stars and black holes. High-energy astronomy is helping us better understand the universe around us. A new tool for the 80s will be the Space Telescope. Weighing 5 tons and measuring 43 feet long by 14 feet in diameter, the Space Telescope will give astronomers unprecedented views of space, unobstructed by the veil of the Earth's atmosphere. The 94-inch primary mirror, largest astronomical instrument ever to be placed in space, is shown here undergoing initial grinding and polishing operations at the Perkin-Elmer Corporation in Danbury, Connecticut. About 300 pounds of glass will be removed during the lengthy grinding and polishing process. The new telescope observatory is scheduled to be placed in orbit by the Space Shuttle in the 1980s and will circle the Earth at an altitude of 310 miles. This is what NASA's Space Shuttle will look like prior to launch. Shown here during a test rollout is the Shuttle Orbiter Enterprise, sitting on top of its large external fuel tank and between 2 solid rocket boosters. The 2 solid rockets will be parachuted back to an ocean landing where they'll be picked up and made ready for another mission. Preparations for the first shuttle launch continued this year, including a water deluge test. 300,000 gallons of water will be dumped on the spacecraft's mobile platform at the time of launch to counteract damaging noise vibrations of the engines at liftoff. The 16 seconds of waterfall has a sound deadening effect as the engines fire. The 3 main engines that will power the Space Shuttle Columbia into orbit were tested at the National Space Technology Laboratory in Bay St. Louis, Mississippi. The main engines are designed to produce up to 470,000 pounds of thrust, gulping a mixture of hydrogen and oxygen. Problems in testing the shuttle engines continue to cause delays. One of the two solid rocket boosters that will burn for 2 minutes with the shuttle's main engines during launch is shown laid out horizontally in preparation for a test firing. The place is the Thiokol Corporation near Brigham City, Utah. Each of the solid rocket boosters produces 2,650,000 pounds of thrust. Small rocket engines called thrusters that make it possible to maneuver the shuttle once in space were also successfully fired at NASA's White Sands test facility in New Mexico. The 154-foot external propellant tank that will hold 1,550,000 pounds of fuel for the shuttle's 3 main engines was rolled out and shipped to the Kennedy Space Center, Florida. The external tank was manufactured at NASA's Michoud Assembly Facility by the Martin Marietta Company. This is Space Shuttle Orbiter 102, christened Columbia. It was named for the seagoing Columbia out of Boston that entered and explored the mouth of the Columbia River in 1792. Captain Robert Gray named the river after his ship. It will be the Space Shuttle Columbia that makes the first trip into orbit around the Earth. The 122-foot-long spaceship, which looks like and lands like an airplane, is being molded into existence by a government industry team of engineers and technicians. 31,000 specially made silica tiles are being mounted on the surface of Columbia, making it possible for the shuttle to withstand repeated heating and cooling, good for 100 or more round trips into space without replacement. Problems encountered in installing the protective tiles have contributed to pushing back the first shuttle launch by several months. Astronauts John Young and Bob Crippen will pilot Columbia on its maiden voyage into space. They are ready, and despite some troublesome delays along the way, all the parts and pieces of the new space transportation system are coming together and approaching launch readiness. There were several major events that occurred during the year, including adding 35 men and women to the astronaut roster. The 35 completed a 12-month training program and will be the pilots and mission specialists as the space shuttle becomes operational. 10 years ago, 3 American astronauts lifted off from the Kennedy Space Center in Florida. 2 of those men, astronauts Neil Armstrong and Buzz Aldrin, became the first humans to set foot on another planet. Much attention was given during the year to the re-entry of Skylab. Launched in May 1973, Skylab was manned by 3 different 3-man crews for periods of 28, 59, and 84 days, during which many scientific experiments were conducted. Since early 1974, the uninhabited Skylab had been slowly descending. Early in the year, it became apparent that the 77-ton space station would re-enter the atmosphere in the summer. Skillful manipulation of Skylab's small amount of maneuvering capability, combined with good fortune, resulted in debris reaching the surface in the Indian Ocean and in sparsely populated areas of Australia, causing no damage or injuries. In space applications, remote sensing from satellites like Landsat are being considered more as operational tools by the Departments of Agriculture and Interior. Remote sensing makes it possible to inventory and predict world food crops, for instance. Consider these pictures taken by Landsat as it tracked the Mexican Gulf oil spill. Large area views like this have been very useful to the U.S. Geological Survey and the Mexican government. Using computers and the GOES-1 weather satellite, NASA is working with the University of Florida and the National Oceanic and Atmospheric Administration to develop a system to warn citrus growers when freezing temperatures are about to occur. This type information alerts growers when they should fire up their oil heaters to save their crops from freezing. NASA's Marshall Space Flight Center has taken technology needed to design highly efficient pumps for rocket engines to develop new, lightweight firefighting water cannons for the Coast Guard. These portable units can easily be transported where they're needed and can draw water from anywhere, including the sea, with a pumping rate of 1,000 gallons per minute. To study the ozone layer and effects of aerosols on that region, a stratospheric aerosol and gas experiment satellite called SAGE was launched from NASA's Wallops Flight Center off Virginia's eastern shore. To compare the information received from satellites like SAGE, scientists and engineers from 5 countries also launched 20 small rocket-borne experiments from Wallops Island. Changes in aerosol concentration may cause changes in climate, with important implications for agriculture. Energy-related research is continuing to be part of NASA's overall effort. A wind energy program supporting the Department of Energy is just one example. The third in a series of 200,000-watt wind generators began operating on Block Island, Rhode Island. It can electrify up to 250 homes there during the winter. That's half the permanent residents on the island. A much larger wind turbine, able to produce 2 million watts of electricity, began operating atop a mountain in Boone, North Carolina. Residents in the Papago Indian village of Stuchalik, Arizona, are enjoying electrical power provided by solar energy. The 3,500-watt photovoltaic village power project was funded by the Department of Energy, the Papago Tribe, Public Health Service, and the Four Corners Regional Commission. It is managed by NASA's Lewis Research Center in Cleveland. NASA's Jet Propulsion Laboratory in Pasadena took delivery of a new electric test vehicle. Developed by General Electric and Chrysler for the Department of Energy, the sleek electric car is scheduled to undergo extensive testing. ETV-1 can range from between 75 and 120 miles before recharging and has a top speed of 65 miles per hour at an estimated operating cost of 18 cents a mile. The car uses 18 lead-acid batteries, good for 30,000 to 50,000 miles, and can be recharged by plugging into an ordinary household outlet for 8 hours. A large part of NASA's efforts are directed toward producing the advanced technology for future aircraft. Case in point, the XV-15 tilt rotor. The tilt rotor combines the vertical takeoff capability of the helicopter with the speed, range, and fuel economy of a turboprop airplane. Rotor aircraft technology like this could add new dimensions to air transportation within the next 20 years. The XV-15 research aircraft was developed for NASA and the Army by Bell Helicopter and recently completed its first in-flight conversion from helicopter to the airplane flight mode. It's called HIMAT, Highly Maneuverable Aircraft Technology. The place is NASA's Dryden Flight Research Center near the Mojave Desert. HIMAT is a supersonic research aircraft that's remotely piloted from the ground. HIMAT has about twice the turning capability of the most maneuverable plane flying today. Data from these flight test programs are fed into a simulator to assess their application to full-scale aircraft. Engineers at NASA's Langley Research Center are studying aircraft structural design, including improved seat and restraint systems that could increase the probability of passenger survival and also reduce injuries when a general aviation airplane crashes. They do this by intentionally crashing planes into the ground at varying angles and speeds. This rocket-assisted crash allowed the researchers to impact the plane at 90 miles per hour. Onboard cameras and instruments give precise information that can be used to improve the crashworthiness of future aircraft. Space science and applications. Space transportation. Wind and solar energy. And aeronautics. All are a part of the NASA story this past year. This special report brought to you by NASA, the National Aeronautics and Space Administration.